Okay, if you've been wanting to build your own TV station with FieldStation42, chances are you've noticed that almost every tutorial out there assumes you're using a Raspberry Pi. I didn't. Not because I wanted to be different, but because where I live, Raspberry Pis were selling for prices that I just couldn't justify. So instead of following the crowd, I decided to see if an Orange Pi could do the job. Now, before I bought one, I actually came across Shane's videos, the creator of FieldStation42, and left him a comment asking whether anyone had tried running it on an Orange Pi 03 with 2 gigs of RAM, or even one of the 1 gig models. His response was pretty reasonable. He said he'd previously tried an older Orange Pi model and wasn't getting the video performance he was looking for. But he also mentioned that if the videos themselves played smoothly, then FieldStation42 should work just fine since the video player does most of the heavy lifting. That wasn't exactly a yes, but it wasn't a no either. At first, I simply ran FieldStation42 on a spare laptop running Linux to get a feel for how everything worked, but I still wanted a small dedicated box that I could leave running without tying up an entire laptop. Originally, I planned on buying the Orange Pi 02W with 2 gigs of RAM. That order fell through, and after reordering, I ended up with something I hadn't planned on at all, an Orange Pi 03 with just 1 gig of RAM. So the question became, can this little board actually run FieldStation42 well enough to become a practical alternative to the Raspberry Pi? Well, let's find out. Now, before we jump into installing anything, I think it's worth taking a minute to introduce the two main players in this project, the hardware we're running it on, and the software that's going to tie everything together. Let's start with the hardware. This is the Orange Pi 03. It's a compact single-board computer that's designed for projects where you want something small, low power, and inexpensive, but still capable enough to run Linux. While it isn't a Raspberry Pi, it fills a very similar role and comes in several memory configurations ranging from 1 GB all the way up to 4 gigs of LPDDR4 RAM. It's powered by an all-winner H618 quad-core ARM Cortex-A53 processor, includes built-in Wi-Fi 5 and Bluetooth 5.0, Gigabit Ethernet, and even supports 4K video output over micro HDMI. For this tutorial though, I'll be using the 1 gig model. That's the version I own, and it's the one you'll be seeing throughout the entire setup process. If you have one of the higher memory models, the overall installation process should be very similar. Now, hardware is only half of the story. The other half is FieldStation42. FieldStation is a free open source project created by Shane that lets you turn a Linux computer into your own retro-style television station. Instead of just playing videos from a folder, it automatically schedules TV shows, movies, commercials, station IDs, guide channels, and other programming, so it feels like you're flipping through an old cable TV lineup. It was originally designed with Raspberry Pi and Linux systems in mind, but it can run on other Linux hardware as well. Put those two together, and you have a tiny computer capable of running your own automated cable box or TV station. So now that we've met the hardware and the software, let's get everything set up. Now that we've introduced both the hardware and the software, it's time to prepare our operating system. Before we even think about installing FieldStation42, there are a few things we need to set up first. Most of these only have to be done once, and they'll ensure everything runs reliably later on. Let's start by installing Armbian. For this tutorial, I'll be using the Bookworm Minimal image. The minimal version doesn't include a desktop environment, which means it uses less storage, consumes less memory, and only installs the packages we actually need. Once the SD card has been written, insert it into your Orange Pi 03, connect it to your network, power it on, and give it a minute or two to finish its first boot. After that, we'll connect over SSH. Okay, open your favorite SSH client. I'm using the command prompt or terminal here, and connect to the Orange Pi using its IP address. The default username is root, and the default password is 1234. So to do that, we go SSH root at your IP address. You can find it on the monitor itself or the other monitor that's connected to the Orange Pi itself. Of course, by default, you have to use 1234, and during the first login, Armbian will ask you to change the root password and create a regular user account. Simply follow the prompts before continuing. Okay, normally I'd recommend keeping your operating system fully up to date. However, for this tutorial, we'll be using the Linux kernel 6.6.75 version, since that's the version I tested throughout this build. Using the same version helps ensure you're following the exact environment used in this video. So to do that, we have to go to Armbian config, next would be to go to System, head to Kernel, and then use alternative kernels. If it says that switching between kernels might change functionality of your device and it might fail to boot, hit yes, because we're only doing this once. So if it asks to show only mainstream kernels on this list, hit no. And what we're looking for here, hold on. Okay, what we're looking for here is the one that uses 6.6.75. It could be either one of these options or this specific option. Anyway, let's go, you know what, let's go pick one of these, specifically the 25.11.2, and then let's wait for it to install. After installing the kernel, reboot the system and reconnect over SSH. Next, we'll prevent future updates from replacing the kernel we just installed. This helps avoid unexpected compatibility issues later on. In this case, we go back to Armbian config, and then navigate to the kernel settings and enable the option to freeze kernel upgrades, which is System, then Updates. First, we'll add the repository that provides the version of FFmpeg we'll be using, then we'll install the remaining dependencies in one go. Instead of using the default FFmpeg that comes with Debian, we're using a customized one from the Armbian forums made by this user named Jock, which is said to enable hardware decoding, or at least that's what it claims. But I highly recommend this. And then now, we can install all the required packages after this quick update. So depending on your internet connection, this installation may take a few minutes. FieldStation42 relies on MPV for video playback, so let's configure it before moving any further. First, let's create the configuration directory. And then let's create the configuration file. And then enter the following configuration. Once you're finished, save the file and exit the editor. Since we're running a minimal installation, we'll configure X11 ourselves. First, let's create a file called .xinitrc inside our home directory. And then we enter the following lines. Okay, what this does is keep the display awake, starts PyCom, and launches a simple terminal window once X, the window manager here, or something like that, starts successfully. Next, we'll have X start automatically whenever our user logs in. In this case, we open the .profile file. And then, at the bottom of the file, we add the following lines. Of course, we have to save the file and exit. At this point, you'll also want to configure automatic login for your user on TTY1. This way, every time the Orange Pi boots, it'll automatically log in and immediately start the session without requiring a keyboard wired to the Orange Pi itself. In this case, we're editing things on a different directory here. We're going to sudo systemctl edit getty at tty1, and then on this empty space here, we insert the service line or the service part here that will automatically log in our user on boot. Next is to save the file, exit, and then run a few more lines. Sudo systemctl daemon reload, and then sudo systemctl restart getty at tty1. Okay, here we go. This is what we're looking for. So if your screen looks like this, congratulations! The Orange Pi 03 is now ready for the next step, installing FieldStation42. So if everything went according to your plan, your Orange Pi should automatically log in like just now, launch X11, and display a terminal window, this white square here at the upper left of the output. That's the terminal window. With the operating system ready to go, the next thing we need is somewhere to store all of our media. While you can technically save everything onto the SD card, I don't recommend it. TV shows, movies, commercials, and station IDs can quickly take up hundreds of gigabytes, and SD cards simply aren't designed to be long-term media libraries. Keeping your media on a separate drive also makes it much easier to upgrade or replace your operating system without touching your collection. And one more quick reminder before we continue. This tutorial assumes you're using media that you legally own or are otherwise authorized to use. Now, let's get our storage ready. For this tutorial, I'll be using a 1TB 2.5-inch hard drive, but just about any external storage device should work, whether that's another hard drive, an SSD, or even a USB flash drive if your media library is relatively small. Go ahead and connect your drive to the Orange Pi. My drive is formatted using NTFS, which makes it easy to move files between Linux and Windows. If your drive is already using another Linux file system such as ext4, you may not need this step. Otherwise, install NTFS support by running sudo apt install ntfs-3g. Once that's finished, we're ready to identify the drive. Next, let's run the following to identify to find our drive. lsblk-f. So this displays all of the storage devices connected to your Orange Pi, along with their file systems, UUIDs, and current mount points. Locate your external drive, usually under SDA1, and make a note of its UUID, which looks something like this. We'll need it in just a moment. Now let's create a permanent location where Linux will mount the drive. For this tutorial, we'll use /mnt/fs42-files. So we do it by going sudo mkdir/mnt/fs42-files. It's up to you on what you're going to name this folder, but in this example, we'll use fs42-files. Next, we'll tell Linux to automatically mount the drive every time the Orange Pi boots. To do that, let's open the fstab-config file by going to sudo nano/etc/fstab. At the bottom of the file, add the following line, replacing the UUID with the one from your own drive, the one we got earlier after hitting lsblk. Using the UUID instead of something like dev/sda1 is more reliable, since Linux may assign different device names each time the system boots. So we save the file and exit the editor. Now that we've updated the fstab file, let's reload the system config by going sudo systemctl daemon -reload, and then we mount everything defined in the file without needing to reboot. Okay, if everything was entered correctly while editing the fstab config, the command should complete without any errors. To verify that the drive has been mounted, run lsblk-f again, and you'll see that the external drive is mounted at /mnt/fs42-files. So from this point forward, the drive will automatically mount every time the Orange Pi starts up. So with our operating system configured and our media storage ready to go, it's finally time to install FieldStation42 itself. With our operating system configured and our media drive mounted, it's finally time to install FieldStation42 itself. Fortunately, the installation process is surprisingly straightforward. We'll start by cloning the official repository from GitHub. Once that's finished, move into the newly created directory. Now simply run the installation script. So this script that you see creates the Python virtual environment and installs all of the Python packages that FieldStation42 depends on. Depending on your internet connection, this may take a few minutes. Okay, once the installer finishes, we're ready to start creating our first TV channel. So FieldStation42 organizes everything into individual channels. Each channel has its own configuration file, schedule, and catalog of media. If you're planning to create multiple stations, you'll simply repeat this process for each one. Let's start by creating the channel's catalog. Okay, let's move into the catalog directory. I guess this was created during installation. Next would be to create a folder for your channel. For the purposes of this demo, I'll call this one TV1, but you can name yours whatever you'd like. Rather than copying all of your videos into the FieldStation42 directory, we'll use symbolic links. So this keeps your media safely stored on the external drive while allowing FieldStation42 to organize everything without duplicating hundreds of gigabytes of files. So in this case, for each show you'd like this channel to broadcast, create a symbolic link to the folder containing that show's episodes. In this example, I'll be making a link to Dan Versus, which is one of my favorites. The important thing to remember here is that this will become the tag that FieldStation42 uses later when building schedules, and repeat this step for every television show, movie collection, or other media library that you want this channel to use. Next would be to create a folder for your station IDs, also known as bumps. If you plan on using commercials, create a commercials folder as well. If multiple channels will share the same commercial library, I recommend using another symbolic link instead of duplicating all of those files across multiple channels. Now let's move back to the main FieldStation42 directory. Next would be to copy one of the example station configuration files into the conf directory. Next is to rename the file if necessary so that it matches the name of your channel. And finally, open the station's configuration file using your preferred text editor. After opening the configuration file for your station, there are a few sections you'll want to customize first. First is your station's identity. Since this example uses TV1, this is what we're going to set it to. You can set it to whatever you'd like to your channel to be called. Next, we choose a channel number. While this example file uses 4, I prefer testing this with 1. Next would be the media locations. First would be to set content dir, or the content directory, to the catalog folder we created earlier. You'd also want to update the bump directory, which is this one, so that it points to your station IDs. And if you're using commercials, set the commercial directory to that folder as well. In this case, I'll keep the name bump and I'll make this commercials. Once those have been configured, we're ready to build a schedule. A FieldStation42 schedule is built around the hours of the day. For a simple station, you can assign a tag to each hour. One example here using that Dan versus example that we had would be to place, I'll just copy this to make things a little easier. So a basic programming block would include something like this. It would say, or it would show the tag. A few things are worth remembering here. Hours must be written as strings enclosed in quotation marks. This uses the 24-hour clock beginning at 0 and ending at 23. Additionally, the tag name must match the symbolic link you created earlier. Since I made the Dan versus link earlier, I have to make it something like this. If an hour isn't defined, or if there's no program scheduled on that hour, the station itself will remain off air unless a previous program continues into that time slot. For now, don't worry too much about making the perfect schedule. So it's perfectly fine to repeat the same shows throughout the day while you're learning how everything works. In my case, let me just repeat this. We'll refine things later once the station is up and running. But before saving the configuration, take one last look at the JSON formatting. A missing comma or quotation mark is enough to prevent the station from loading correctly. When everything looks good, save the file once. If you're planning to create additional channels, simply repeat this process for each one. With all of our channels configured, it's time for FieldStation42 to scan the media library. Make sure that the Python virtual environment has been activated first, then we build the catalog. So yeah, FieldStation42 will now scan your media, build the catalog for each configured channel, and prepare everything needed for your TV station. Once the process completes without any errors, your channels are ready. Pitaju me u mom kraju ko da ne znaju, zašto mi se usne više nikom ne daju. Pitaju me u mom kraju ko da ne znaju, da se suze kao laste uvek vraćaju. After everything we've done up to this point, it's finally time for the fun part. Let's see our TV station come to life. Since we're already in the Python virtual environment, all we have to do is launch the player itself. Okay, looks like we're having an issue starting the player at this rate. In this case, we have to put in another line here or another script here or run something that can configure this to run at startup. So we close this one due to this issue that we're having, and then we install the services. When prompted, we only enable fs42.service. This allows FieldStation42 to automatically start whenever the system boots. You'll also notice that there are a few additional services, including support for the cable box interface, which we'll set to no, the remote controller, which is also something else. For now, we'll set this to no. And then the OSD. For now, this is an advanced feature. We'll also set this to no. Those are useful features, but they'll each get their own dedicated videos, so we can give them the attention they deserve. For now, only the core service is what we need. So all we have to do is restart this and wait for it to come back. Oh, okay, we've got FieldStation42 starting. This is the part that we miss. This is a good sign. So yeah, let's just stop this part in case we run into, issues. Okay, and there you have it. That's how to make FieldStation42 work. So, for this tutorial, I kept things intentionally simple by creating a single station so we could focus on getting everything working from start to finish. Because of that, I won't be demonstrating the guide channel just yet. That feature really starts to shine once you're running multiple stations, and that will be in a future video. That said, while I was learning FieldStation42 and porting everything over to the Orange Pi 03, I ended up building a few channels of my own. This is RNHKNP1, my main TV channel. And alongside it, I also created RNHKNP2, which focuses on movies and entertainment programming. These channels weren't built specifically for this tutorial. They're the result of experimenting with FieldStation42 over the past few months and gradually moving everything onto the Orange Pi 03. For me, they also answer the original question that started this entire project. Can an Orange Pi 03 with just 1 gig of RAM actually run FieldStation42? At least in my experience, the answer is yes. Shout out to Shane, who goes by Round Dog Reckons on YouTube, for building such an awesome project. And that's it. We've installed Armbian, prepared our media drive, installed FieldStation42, created our first channel, built our catalog, and successfully launched our own TV station. From here, there's plenty more to explore. In future videos, we'll look at creating multiple stations, using the guide channel, setting up the cable box interface, configuring remote controls, and taking advantage of some of the more advanced features that FieldStation42 has to offer. If this tutorial helped you get your own station up and running, then I'm glad it could help.